Module 1, Session 3. Session 3 will cover Learning Outcome 5.1.1, Part 2. Use compound growth formulae. Learning Outcome 5.1.1, Part 2. Use compound growth formulae to solve problems. In this session, we revisit compound growth. Although this topic is not new to students, they still struggle with the more complicated examples in Level 4. With compound growth, the key point to remember is that interest is not just being earned or paid on the principal amount, but also on all interest accumulated in previous periods. So how does compound interest work? Let's look at an example. We start with 100 Rand and invest it at 10% compounded annually. After the first period, interest is calculated on the principal amount. So after 1 year, we have 110 Rand in the bank. After the second period, interest is calculated on the principal plus the interest earned in the first period. So after 2 years, we have 121 Rand in the bank. After the third period, interest is calculated on the principal, plus the interest earned in the first period, plus the interest earned in the second period. So, after 3 years, we have 133 Rand and 10 cents in the bank, and so on. Calculating compound growth is made simpler by applying the compound growth formula, which students should be very familiar with. Let's apply this formula to the previous example where we invested 100 Rand at 10% compounded annually. After 3 years, we have, which equals 133 Rand and 10 cents. This is the same as the value we calculated in the previous example. Your students should remember that the compound interest formula is an exponential function. Looking at this graph, we can see that the red compound interest function gets steeper and steeper over time, showing how the rate of growth of the invested amount increases over time. Herein lies the power of compound interest. Compared to the simple interest function, the invested amount grows at the same rate over time. Students really struggle to understand how to apply the compound growth formula to different compounding periods, even by fourth year level. Let's hear more from a lecturer.
As it is the case overall in mathematics, learners don't read financial maths is word problems. They don't read. They read, they scan, and then they don't see an action word like, if I can use whether it's compound or simple interest or decreases. Words like, okay, annually is always there, so they assume it's always the case. But then you see inside the fine print, semi-annually. What does that mean? Semi-annually? Semi is 2. Divide by 2 times 2. That's half yearly, it's exactly the same. Quarterly. Divide by 4 times 4. Monthly, divide by 12 times 12, because there are 12 months in a year. Daily, divide by 365 times 365. And those keywords, normally John Cena them, because they don't read the question carefully.
So how do we adjust the formula when working with different compounding periods? The formula becomes this, where M is the number of times that the growth is compounded annually. Let's look at some examples of different compounding periods. If the growth is compounded semi-annually, that's twice a year, then the formula will look like this. If the growth is compounded quarterly, then the formula will look like this. If the growth is compounded monthly, then the formula will look like this. If the growth is compounded daily, then the formula will look like this. Let's look at an example where a lecturer works with different compounding periods.
Putti invests 10,000 Rand for a period of 5 years. What will the final amount be if the amount is invested at these different terms of investment? What we must understand with this question is that the period, which is n, is always equal to 5, and the rate at which the interest is charged is also staying the same at 7%. We will see that this is a traditional compound interest, simple interest question. Therefore, we must be familiar with the simple interest formula as well as we must be familiar with the compound interest formula. So it is very important that we note simple interest, which we note it as SI, gives you a formula of A, which is a final amount, equals to principal amount, open bracket, 1 plus interest times the term of the investment, which is N. Also, it is important to note as well that your compound interest is calculated as A equals to P, open bracket, 1 plus I to the power N. Now, just to explain, for the sake of understanding what each of these terms mean, A is the final amount after the investment, so this is at the end of the investment. P is what you have put in your investment. I is the interest, is the interest, not the interest rate, because R will then be the interest rate. Here, I is just the interest and R is the interest rate. So I is equal to the rate at which the interest is charged divided by 100. So in this case, is equal to R over 100. So what we then see here about I then is the same as R over 100. Other people would just prefer to put R over 100 here, which is exactly the same thing. And N is the duration or the period of your investment. Now, it is always important before you solve the problem of this nature, write down what you are given. So we are given P is equal to 10,000. We are given I is equal to, you can see 7% is all throughout, so it's going to be 7 over 100, which is equal to 0.07. Please use your calculator to verify that. Don't just look at it and say it's the value. I know it through years of experience, but you must just check it to confirm. And then N is equal to 5. What then you need to understand is what the question requires of you. In these questions, you can either use this or that, any of those formulae, but you can't use them both in one question. That's obvious. Simple interest. So let's say now, what will the final amount be if the money is invested at 7% simple interest annually? So simple interest formula is what we need here. What does that mean? It means that you want your A, your P is 1,000, I mean 10,000 rather, pardon me, and then 1 plus your I is 0.07. N is equal to 5. That means that after 5 years, simple interest annually, you will have a final amount of, let us write it here, 10,000, open bracket, 1 plus 0.07 times 5. We put that whole calculation here, press equal sign. That means that your investment at the end of 5 years will be 13,500 Rand. That's the amount for A. That's the final amount of the investment. We therefore go to B. Now B goes for compound interest, but again, compound interest per annum compounded annually. Compounded annually, what does it mean? It means that there's no adjustment taking place on our rate of interest. There's no adjustment taking place as well as on our term of the investment, which is your period. We're just going to substitute on the compound interest as where it is. Let's substitute P, open bracket, 1 plus 0.07 to the power of n. In this case, n is 5. I would like to just expand this bracket for the sake of explanation. So you have 10,000 here. You have the opportunity and the right to add these, so which gives you 1.07 to the power of 5. Then that solution is what you will calculate. Go to your calculator. 10,000, open bracket, 1.07, close bracket, to the power of 5 equals to. So you can see that if you have invested in compound interest exactly with same terms, except for the fact that you are using compound interest in terms of simple interest, you will get 14,025 rand 52 cents. So in compound interest, you are getting more than in simple interest. And of course, that means that it's obvious because it's calculated with an exponential form of your n. Then we need to focus now. Why do we need to pay attention? Simply because here now we're saying your money is invested at 7% compound interest per annum, compounded quarterly. Now, quarterly means that as opposed to annually in B, quarterly now is going to ask yourself how many quarters are in 1 year. So how many quarters are in 1 annum? Of course, that means that you're going to say 12 divided by, how many quarters are there? 4. So it means that now everything changes in terms of your interest, because there are 4 quarters in 1 year, which means that for your interest, you divide by 4. For your n, you multiply by 4, because this is quarterly. How many quarters are in 12? Are in 1 year? 4 quarters in 1 year. We're going to see now what I meant by that. Same compound interest formula, except here now we divide by the number of these in 1 year. There are 4 of these in 1 year. Here we multiply by this. That's the only difference. Therefore, go back to our calculator. Which is I over 4, close bracket, to the power of n, which was 5, multiplied by 4. We can have this solution straight from our calculator. You even get more if your interest is calculated and the compound interest quarterly. You get more than someone who's calculated annually, and this is the difference. So which means that you'll get 14,147 rand 78 cents. Number D. In this case, compounded interest per annum, compounded monthly. You ask yourself, how many months are in 1 year? 12 months. So you're going to divide by 12, multiply by 12. Straight from our calculator, and because of we didn't delete anything on our calculator, we can just come back here, and because of instead of 4 we delete and we put 12, we go into our bracket. Instead of a 4 again here, we say divide by 12. Everything is still the same. So which means that here in this case you will get 14,176 rand 25 cents. Number E, compounded interest per annum, compounded daily. Daily. Now, how many days are in 1 year? We always use the traditional one saying there are 365 days. So the standard one you must use here, it's 365. This interest must be divided by 365. Open bracket, close bracket, n times 365. Nothing else changes. Which means that we then have the upper hand of coming back to our calculator because we didn't disturb on it. We just changed 12 to 365. Your value becomes even more. Now this is very important. Let's focus here quickly. This is very, very important. Your currency is always to 2 decimal places. And what we have here is that it's 1.99, which means that this 9 will affect this 9 to make this whole thing to be a 10. And of course, we cannot have a 10-10, which means that it's going to be 20, which is 20 cents. So it's going to be 14,190 rand 20 cents. So we have successfully calculated A, B, C, D, and E.
Now try this example on your own. 2.5 years ago, Andile invested an amount that earns interest at 8% per annum, compounded quarterly. An amount of 15,000 rand is now available. What was the original amount he invested? Let's have a look at the solution.
Let us look at the following problem. 2.5 years ago, Andile invested an amount that earns interest at 8% per annum compounded quarterly. An amount of 15,000 rand is now available. What was the original amount he invested? Compound interest is payable or earned on both the principal amount and the interest earned on the principal amount. The formula for compound interest is given by the following and is equation 25 in your formula sheet. As with simple interest, A is the total amount payable or available at the end of the loan or the investment period. P is the initial or principal amount borrowed or invested. I is the interest rate per annum, and N is the number of years. Now, if we go back and look at the problem, it says that Andile earns interest on his investment at 8% per annum compounded quarterly. The formula for calculating compounded growth, where the interest rate is compounded annually, monthly, or daily, is given by the following. M in the formula is the number of times that growth is compounded annually. Since the interest rate is compounded quarterly in the problem, M is equal to 4. A, which is the accumulated amount, is equal to 15,000 Rand as per the problem. Interest earned is 8% per annum, compounded quarterly. And given these variables, the number of years is 2.5. Given these variables, we can now plug them into the simple interest formula, into the compound interest formula, and calculate the principal amount. Simplifying the equation, we get the following. We then go ahead and divide the right-hand side and the left-hand side of the equation in order to isolate P. We cancel out the like terms at the top and at the bottom, and we are left with P is equal to 15,000 divided by 1.219. We then get a final value of 12,305 Rand and 17 cents. Therefore, Andile invested a principal amount of 12,305 Rand and 17 cents.
Work on this example with the person next to you. It is a little more complicated with different compounding periods as well as deposits and withdrawals. Let's work through the solution with the lecturer.
Let us look at the following problem. David won 10,500 Rand in a writing competition. He deposited 10,000 Rand into a savings account. The interest rate was 9% compound interest for 2 years, then it changed to 10% for 1 year and 11% for the rest of the time. After 3 years, he deposited 2,000 Rand from his annual bonus because he did not go on holiday that year. After 7 years, he experienced some difficulty and withdrew 3,000 Rand. How much money did David have after 10 years? In problems like these, it is useful to draw a timeline. And this is because in these type of problems, there's a change in interest rate, and there might also be changes and additional withdrawals or deposits. So we're going to begin the problem by drawing a timeline. The question asks us how much did he deposit after 10 years. Therefore, the timeline spans over a period of 10 years. It will extend from T0 all the way to T10. The question says that he deposited 10,000 Rand into the account. So this is his initial deposit. The interest rate was 9% compounded interest for 2 years. So it was compounded at 9% for 2 years. The rate then changed to 10% for 1 year. So this indicates that it changed changed from T2 to T3. And later, it changed to 11% for the rest of the time. So from T3, at the end of T3, all the way to T10, the interest rate remained at 11%. After 3 years, so after his initial deposit, he deposited 2,000 Rand from his annual bonus. So at this point, he deposited 2,000 Rand. And after 7 years, he experienced some difficulty and withdrew 3,000 Rand. So at this point, he withdrew 3,000 Rand. Now that we have our timeline, we can begin to work out how much he has after the 10 years in a series of steps. Now that we have a picture that summarizes David's financial situation, we can calculate how much he has in his account after 10 years. We begin by calculating the capital amount after 2 years. So this is the amount that he has invested during this period. We use the compound interest formula. The principal amount is given as 10,000 Rand. The interest rate is given as 9%. And the amount has been invested for 2 years. Simplifying the equation, we get an answer of 11,881 Rand. So as mentioned, this is the amount that is available in his account after 2 years. We then calculate the amount that is available after 3 years. We first calculate how much he has earned on the principal amount based on the interest rate. Once again, we use the compound interest formula. The interest rate is given as 10%. Remember, the new principal value is the amount that was available in his account after 2 years. We calculate this equation for a period of 1 year because at the end of the 3rd year, a deposit was made into the account. So therefore, we only calculate the equation for a period of 1 year. Simplifying the equation, we are left with an amount of 13,069 Rand 10 cents. We then have to consider the deposit that was made into his account. So we simply take the amount available after 3 years and add the deposit of 2,000 Rand, which gives us the new principal amount of 15,069 Rand 10 cents. We then go on to calculate the capital amount after 7 years. Once again, we use the compound interest formula. The principal amount is the new accumulated amount as calculated previously. The interest rate, as indicated on the timeline, is given as 11%. And we are calculating the amount for a period of 4 years. Simplifying the equation, we get an answer of 22,875 Rand 95 cents. At the end of the 7th year, there was a 3,000 Rand withdrawal. Therefore, we take the accumulated amount and we minus the 3,000 Rand withdrawal. We are then left with a final amount of 19,875 Rand and 95 cents. The last step is to calculate the capital that is available after 10 years. And this is after the initial 10 years after the initial deposit. We use the compound interest formula. The new principal amount is the latest accumulated depreciation amount, the latest accumulated amount. The interest rate is still given as 11%. And we are calculating the amount in the account for the remaining 3-year period. Simplifying the equation, we get a final answer of 27,182 Rand and 97 cents. Therefore, David has a total amount of 27,182 Rand and 97 cents after the 10-year period.
Inflation is the percentage increase in the cost of goods and services from one year to the next. We use the compound growth formula to calculate inflation. This allows us to calculate the increase in the cost of living. Now try this activity on your own. The average rate of inflation over the past 5 years was 8% per annum, and a 2 kg packet of rice currently costs 20 Rand. Answer these 2 questions. Let's see how a lecturer works through the solution.
Now, before we begin the next problem, let us talk a little bit about inflation. Inflation is the average increase in the cost of goods and services from one year to the next. Inflation is expressed as a percentage per year. In effect, inflation represents a decline in the value of purchasing power of money. If we know the rate of inflation over a given period, we can use the compound growth formula to calculate the increase in price of goods and services. Let's look at the following problem. If the average rate of inflation over the past 5 years was 8% per annum, and a 2 kilogram packet of rice currently costs 20 Rand, calculate how much a 2 kilogram packet of rice can be expected to cost 5 years from now if the rate of inflation remains the same. As mentioned, when calculating inflation, we use the compound interest formula. The principal amount is given as 20 Rand. This is indicated in the problem. The interest rate is given as 8% per annum. And we are calculating the rate of inflation over the past 5 years, or rather, how much the packet of rice will cost in the next 5 years. Therefore, the value of N is 5 years. We then simply plug in all the variables into the formula, and once simplified, we get a value of 29 Rand 29 Rand and 39 cents. Therefore, we can conclude in 5 years' time, a 2 kilogram packet could be expected to cost 29 Rand and 39 cents. The next question looks at how much a 2 kilogram packet of rice would have cost 5 years ago. So we use the same compound interest formula. However, in this problem, we are given the accumulated amount, which is 20 Rand. The interest rate is still 8% per annum. And we are looking at how much the rice would have cost 5 years ago. Once again, we simply plug in all the variables into the equation. We then isolate P, and we do this by dividing both sides of the equation by the variable that is attached to P. We cancel the like terms at the top and at the bottom, and we are left with the following equation. On simplifying the equation, we get an answer of 13 Rand and 61 cents. An alternative solution is to simply isolate P in the initial equation. And we do this in a similar way that was done in the previous method, whereby we divide the right-hand side and the left-hand side of the formula by the variable that is attached to P. Again, we divide the bottom, we cancel out like terms at the top and the bottom, and we are left with the following formula. Once again, we plug in all our values into the equation. And then simplifying the equation, we are left with the final answer of 13 Rand and 61 cents. This answer is the same as the answer that we got in the first method, and we can conclude that a packet of rice would have cost 13 Rand and 61 cents 5 years ago.
That brings us to the end of this module. In the next module, we will be looking at tax tables and tax returns, as well as the decay formulae.